Next, we're going to talk about the binomial distributions. Okay, we already calculate that the probability of 3 heads equals to 1 over 8, 2 head is 3 over 8, 1 head is 3 over 8, 0 head is 1 over 8. So when we see, we won't just care about the number of head that we can get from 3 coins. Then we can have this histogram. We plot the outcome in this histogram. First, how many percent that we can get if we only want 0 heads? So this one equals to 1 over 8, this big. And then how about 1 head? 1 head we can get 3 over 8, so this big. And then if we want 2 head, we can also get 3 over 8. And the other way, if we can only have 3 head, that means we can only have 1 over 8 probability. Okay, if we see this graph, it's symmetrical. Okay, next. So this is called binomial distributions. It's discrete, yeah, it's actually histogram, but bell or half bell shape, like this, like a bell. Okay, for example, the bell-shaped distribution of height, IQ, etc. Yeah, okay. So how about the normal distributions? We already talked about the binomial distributions. Normal distributions, actually, it's bell-shaped distributions, but it's for the continuous number, yeah, continuous data. Okay. It follows the Gaussian distributions, which is the probability is given by these formulations. Okay, not all bell-shaped distributions are normal, but it is generally a reasonable start. Not all binomial is normal distributions. There is some specific characteristic that make them normal distributions. The properties are where the number of the sample equals to unlimited, yeah, infinite. That means it's a lot. Instead of n, number of sample, and p, probability, the parameter are the mean, yeah, the mean, the average, and the standard deviations. So in the normal distributions, we don't use the n and probability. It truly is bell-shaped. Since x is continuous, it is perfectly smooth. Okay, how we interpret the normal distributions? For example, IQ is normally distributed with mean equals to 100 and standard deviation 15. That means about 2% of people have IQ above 130. So it lies in the blue area in here. This is how we read the normal distribution. So the normal distributions is always shaping like this, the same between the left side and the right side. This is the mean, yeah, mean 100. And then this is the standard deviations between the middle part to the left, to the right wing, and to the left wing. This is standard deviations. Yeah, this is 15, this is 15. What is not normal? Not all bell-shaped distributions are normal. For example, stock returns are log normal with fat tails. Mixture of normal distributions are not normal, like full populations of height. So if we just count the woman height, that's follow the normal distributions. If we also only count the man height, this also follow the normal distribution. But when we combine them together, it can be like this, skewed. Yeah, it's not normally in the middle. Okay, that's it for our session today. So this slide is modified from Skina's slide, and this is the textbook that we use in this topic. Thank you for listening.